Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in the series of data structures and algorithms, let's learn the popping the first element in a doubly linked list. So now this is the doubly linked list. So when I say pop first, we are removing and returning the first node in this doubly linked list. So what is the first node? This one, right? This is the first node in the doubly linked list. So how are we going to remove it? When you wanted to remove, the first step that we need to take is first we have to move this head to the next one, correct? That's when this will become the head and we will remove this first element from the doubly linked list. And what is the second step? Once this 2 will become the head, then we have to point the previous to the none. That's when this entire thing, this entire thing means this entire head currently what is pointing to the first node, right? That will be removed and will be returned it to the list. Okay, so now as I said, it contains two steps. First one is pointing the head to the next, and then pointing the after moving it we will point this node 2 to the none. Okay, now let's code for this. So here also we have to see what is the list is empty, like edge cases we have to see when there is only one element, because here this is kind of deletion activity, right? So all the three edge cases we have to see. First one is what if list is empty, second one is only one element is in the list, and the third one is when there is proper list and you wanted to remove the first node in the list. Okay, now two things that we discussed, right? What are the two things? Is first is you have to move the head to the head dot next to the, moving this pointer to the next element. So we will say self dot head equal to self dot head dot next, which means that the pointer will be pointing to the 2 instead of 1. Okay, this is where this entire thing is gone. Now only now here we have the head. Now what is the next step? Now this is the head. So what is head of previous is this arrow, this particular arrow. Now it should point to the none, so that it will become the first element of the list. So self dot head dot prev equal to none. That's all. It will pop the value. Now let's go back to our online compiler, and I have the code handy for till we have done in the previous class, right? The doubly linked list class, where we have done till prepend. Okay, now let's write the code for pop first. So as I mentioned, we have to while coding this we have to consider the pop first, and we don't have to pass any data because this is a deletion operation, and we have to make sure that we are coding for the corner cases as well. So first one is, let's say list is empty, means if self dot head is none, right? Which means that list is empty. Then maybe we can say print list is empty. In all the other above cases also we can add proper print statements. Okay, return none in that case, because we cannot do anything because already list is empty. We cannot remove anything where there is actually nothing. And now we have to return the popped value, right? So I will say popped value equal to self dot head dot data, because this is the first element that we wanted to remove, right? So that's why head dot data we are assigning it to the pop value. There is a temporary variable that we are taking, and we are storing the head dot data into that. Now let's say there is only one record is present, only one node is present in the list. That time when there is only one node, what will happen? both head and tail will be pointing to this only one node. So let's say there is one node, then to the same we will have head and to the same we will have the tail pointing, correct? This is how it will look like when there is only one node. So for that we will say self dot head equal to self dot tail, which says that if both the pointers are same, which means there is only one node is present, then that node we have to remove it, right? So we will assign both head and tail to none. So self dot head equal to self dot tail equal to none, so that whatever already is there, that we are removing it from that single node list. Now this is where we have to use the code that we have just written, and we will put it here. So now what we have done, we have first we have assigned the next element as head, and then to the previous we are assigning to none, so that in between that one is there, right, which is totally removed. This one is totally removed. And finally we will return the pop value, this value, whatever node that we are removing, so that we know what value is being removed from the list. Now we have the print list here. We have this using the append, we have created a doubly linked list with the 5 values. Now we'll say print of dll dot pop first. We don't have to pass any value, and then we will say print list after. Okay, now let's run this code. If you see here, first we had 5 elements in that doubly linked list, then we popped the first one, that is our main intention, right, popping the first element. And after that if I print the list, it doesn't have the one node, mean the first node, only it has the remaining 4 nodes. Okay, this is how pop first works in the doubly linked list. Okay, now coming to the space and time complexity of this one. So usually, right, I mean earlier I have just explained as a overall time complexity, but usually how we have to check is wherever we have these conditions, and for each set of code we have to check the time complexity or space complex time complexity mainly, and then for all the code lines we have to check, and based on that only we will be identifying the proper time complexity. For example, if you take this if condition, right, so it is checking if the head pointer is none or not. So it's a kind of a straightforward, it doesn't have to traverse through the entire list to find that out. So for this the time complexity is order of 1, and similarly here also it is checking the so accessing this pop value, when this one, right, for this line also we should not leave like that. So we are just assigning the value of the data which is present in the head to this pop value. So here also the time complexity is order of 1, and similarly we have to just check for time complexity for each and everything. And if you see the majorly, right, we are just playing with the pointers here, assigning here and there, and we are not actually doing something like for loop, right, where again and again we have to do something. So that is not there, right? So because of that this time complexity of pop first is order of 1. Okay, and coming to the space complexity, you can see here, right, we are just moving the pointers and we are not actually have getting into a situation where we need an additional space required, right? So for that space complexity is also order of 1 for this. Okay, hope this is useful for you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.